What's up everyone? In this video I will try to go through all the features on the tool that I have been working on, and this tool is all about instantiating and copying geometry along the curve. This tool really came from the need of different logic for different modular geometry collections. So if you go to something like a Megascans or any collection of kind of themed packs of geometry, you'll see that there's something like this where you have these modular pieces. And you can see that many of them are not really, basically, many of them require different kind of logic to be effectively instantiated or copied around. So this tool kind of tries to solve it by creating different logic that you can switch between depending on the geometry that you are inputting into this HDA. And let me go through this HDA really quickly. But for that, I want to say that this tool is very much still work in progress, and if you find this video interesting or this tool useful, what I want for you to do is to basically, if you find it useful and you get it, what you want to do is go ahead and join my Discord server, and there's going to be a separate channel for the feedback on this tool, and I am really want to see some feedback on how can I improve it, and finding different bugs and adding new features to it. So this is still very much a work in progress for me, but I feel comfortable enough to share it with you, to get some feedback on it and to improve it, because I just need for people to start using it and giving me some feedback. So for me the planned improvements is to have an Unreal integration, a documentation of the HDA, which includes the documentation of the help file, and also the internal network documentation, which basically explains every part of the HDA internally, and also the general improvements of the UI and all of that. So yeah, and let me go ahead and start going through this HDA and explain you kind of a core philosophies of this HDA. So this file will be provided if you get this tool, and one thing that is not going to be provided are these files that I have downloaded from the Megascans. Because of the copyright issues, I can't really distribute them on the zip file, so I'm going to basically just delete them, and I'm probably going to maybe point to the unique ID of this geometry here, so that you can go ahead and download it by yourself, or give it something like a similar geometry to it. But for demonstration, I'm going to leave it. So let me go ahead and go through this tool. I'm going to start by a little bit with this setup that I have here, and the HDA node will be this one, and it can be a little bit confusing to look at it, but once you understand the core concepts of it, it's actually pretty simple to use. So in this case, the mode selection is on the very top of this HDA. You see there's a mode. Right now there are 5 modes, and in this case I am using a bend mode. And bend mode is very simple. We are basically bending geometry around the polycurves that we are actually giving this HDA. And in this case, I basically created this kind of like a test based geometry and created polycurves around it like that, and I wanted to create a railing around it. And this is the end result that I got, which is very simple railing. And what's cool about this, HDA is also going to give me the output curve that was generated when the bend happened around the polycurves. You can see I get this beveled curve, and then I basically can modify it and add this railing, and the output is something like this. What's cool about this, I can go ahead and work with this. Since the tool supports multiple polycurves, I can go ahead and create something like this, procedurally cut out some cutout parts for these polycurves, and going to procedurally set up everything correctly. So this is a kind of a little bit, it's not really instantiating geometry, but copying geometry. Let me go through the setup of this one. So in this case, if you have set up your bend, if this is a bend mode, you want to go to the tab that has a bend mode tab, and you can specify the source for this geometry. In this case, I have the source is a pattern, but what you can do is also, since we're just bending the same geometry along the polycurves, you can just provide, just like with this sweep node, a simple shape. And if you go ahead and say, okay, I want to actually use my third input from the HDA and use the shape and sweep it around the polycurves, you can just go ahead and say, okay, sweep it. You can see now the geometry is being, this circle geometry is being swept. And if you go ahead and change the resolution, you can see it's a lot lighter geometry right now. And what's cool about this, you can go ahead and change the bevel on it. And the roll, which is just a rotation like that. Let me give it to the control element, the default one. But let's say I have a very specific geometry that I want to bend around. So this is where the pattern node, comes in handy. So you press on the pattern. What you need to do is provide this HDA a source geometry to bend around. And this comes from the second input of the HDA. So inside here, what I have here is basically a couple of straight pieces, three straight pieces that can be bent around a polycurve, and couple of angle pieces that are not actually used in this example, but I do have a couple of straight pieces and also a couple of cap pieces. So very important thing for you to do is correctly setting up the attributes that are going to be read from this geometry. In this case, since the bend mode is probably some of the more simple one in this tool, you only need one attribute set up on your geometry, which is the ID. So the ID, it doesn't really have to be specifically called an ID, but it does have to be a string point attribute that holds the unique name for each piece that can be instantiated or copied around geometry around the tool. That's the tool going to use to separate each geometry. And in this case, I have a prefix for the straight geometry, straight 0, 1, and 2. Then I have two caps, a cap end and cap start geometry, which is basically just the caps for each polycurve start and end. And then I have a corners. You can see all of them are prefixed, basically a prefix and then underscore and then the unique. For the corners, I have specifically give it the angle that it has beveled, and for the caps, I just gave it a unique ID like a 0, 1, and 0, 1. So this is the only attribute that is needed for the bend mode. And to set up what kind of geometry is being bent around, you have to go to the common controls. In the common controls, you can control so this is common controls is used to basically the controls that are universal to all of the modes. Well, at least intended. So right now, that's not exactly correct because some of the modes are not using all of the options of that are under this tab, but most of them are already implemented. So in the bend mode, what we can do is basically say I want a pattern to be bent around these polycurves, and it's very simple. We can go ahead and say, okay, I do not want to bend around the straight piece 0. Let's say I want to straight piece 1. And you can see I am now bending around the straight piece 1 around it. Let's say I want to straight piece 1 and then followed by straight piece 2. You can see we are now repeating straight piece 1, 2, and then repeated. This pattern is repeated along all of the curves. And then I can also say, okay, do I want a cap geometry? You can see in this case, I have a special cap geometry that has basically just a straight piece that has been beveled that the beginning has been beveled. Let's say I do not want it. I can say, okay, I do not want to cap this geometry, you can see now the pattern starts without the cap, and the end it's basically the same. And what's cool about this is that this is going to be automatically picked up by the tool as long as you have set up your prefixes correctly. So you can see that under this drop-down menu, it's not going to give you an option to select a straight piece, or in this pattern, it's not going to give you an option to select select something like corner pieces or cap pieces because of the prefixes setup. And the prefix setup is done in the setup tab. So whenever you are inputting your geometry, you want to go ahead and you want to go straight away to the setup and setup tab and pick your prefixes and attributes that point to the information that HDA requires. And since this is a bend mode, it requires only one piece attribute. And if you press on the drop-down menu, you can see it's going to show that we have only one valid ID, a valid attribute, which is ID. So this is also set up so that it shows only point attributes that are strings. So it's not going to show like any integer or any other attribute type that is not integer and it's not a string. So these are drop-down menus are set up so the correct information is always set. And the piece identification prefixes are very important. So ideally, they should be set up something like a corner, straight, and cap ID prefixes, so that it's by default picks them up. So the tool automatically picks them up without a manual adjusting of them. But if your pieces are named something like prefix with something different, we can go ahead and it's also tool is going to automatically extract the prefixes from all of the ID attribute values. So the prefix is generated from any string value before the first underscore is going to be considered as a prefix. You can see it automatically has picked up all of my prefixes that I have set up, and if my prefixes would be like something like a not straight but something different, all of these would be also picked up under this drop-down menu. So this is kind of like a convenience setup for you to quickly set up your attributes. So for now we can just leave this one, go back to the bend mode, and the bend mode is basically pretty simple. And we can also enable fusing if you have something geometry like this, that so for the straight pieces there are no caps, you can easily go ahead and fuse the geometry together. So internally, this tool basically uses a little bit modified version of the what's the tool is called? Actually, I forgot what's the along the. So the name of the tool that's used internally is I forgot. So let me actually go ahead and go inside. No, it's a chainsaw. So it's a little bit different. It's basically little modified and simplified workflow for the chainsaw in this one, and for the for the sweep, it uses the modified version of the sweep node. And the code that is being outputted can be modified. In this case, I am basically making this curve a little bit shorter to remove the edges that are facing downwards. Let me show this downwards, and then I'm using a curve swap to make it a little bit shorter. Then I resample it and I just copy these poles. Then we can go ahead and merge them together. You can see you're getting this kind of a railing effect on this tool. We can go ahead and use like a boolean for this one, and you can see it's procedurally being modified. So this is a railing mode. So this is some of the more simpler geometry that you can generate with this tool. Let me go to the next one, which is the Pathdeform. So Pathdeform tool is also probably more of a more classical copy copy to points, when you think about copy to point geometry that is being basically instantiated, which is not being, so the geometry is not going to be bent. It's just going to, the tool is going to check for the attribute, which signifies how big the piece is, and then the next piece is going to be, and then this size attribute is going to be used to align geometry along the input curve. So in this example, I have these very simple walls that came from the Megascans. These ones, you can see it's a super simple geometry. We have a cap beginning and the cap end and the middle wall, and that's it. So this is a very simple geometry to create a line with this tool. We just go ahead and create our attribute. In this case, we still need our ID attribute, and but also since we want to align it along the curve, we need to know its size. And in this case, I'm just using the size as the bounding box.z, bounding box size of it, for all of these pieces. And basically, since the geometry is aligned along the z-axis, it's going to ideally align with the polycurve. Then just merge it together. Let's go to the polycurve. So inside here, so this mode is going to be called the Pathdeform mode. In the setup, now that we have selected Pathdeform mode, you can see we have our ID, but also we need our size. And also size attribute is automatically picked up, basically automatically going to be here as only valid attribute that we can use as a size attribute. And the piece identification is basically the same. And let's go to the Pathdeform. There's a couple of options which are not, for this example, not really all that interesting. But we still have our common options. And in the common options, we still have to use the pattern. And since I have only one straight geometry, you can see it has only gives me option to only instantiate this straight piece 0, but I still have my cap geometry. You can see this cap geometry, I can disable it, and both sides like that. And really, this geometry only works with this straight polycurve, so it's not very exciting thing to do, but these walls look really nice, and there's really no seam between. Since these seams are basically all the flat, they need to align perfectly with each other. So this is a very simple Pathdeform example. So let me go ahead and show you another one. And this one is also from the Megascans. In this case, you can see that this kind of fence is not very. It can have a little bit of a randomness to it because it looks kind of like a little worn down and not very well. Just by the fact that it's just a wooden fence, it doesn't have to be perfectly aligned with the ground. It can have some randomness to it. So this is where the size of it. So there's really only two pieces of it. So you can see here have the long piece and the cap piece. We just merge them together, and the bounding box is still being used as a Z bounding box. So all of the pieces needs to be aligned with the Z axis to be aligned correctly. Inside here, I have an option to have a little bit of a randomness, random rotations. So if you go ahead and check out this one, you can see we have a little bit of a random roll for each piece, random yaw, and a random pitch. So this is going to give it a little bit more of a natural look for something like for this fence. And now let's take a look at a little bit more advanced usage of the polypath mode, which is these road barriers. So in this case, I also have only 4 geometry pieces, and in this case I'm only using 3 of them. So we have 2 caps, start and end cap, and the main piece, the middle one. And to show how it works, I want to show another feature of this tool is to have manually adjusting the size that the tool is using it for the instantiation. So in this case, what I have here is this geometry. And let's say I want to overhang this geometry a little bit more. So in this case, you can see that this geometry connects, and it wouldn't really make sense that right after the geometry, like the cap start ends, the next one starts here. So I want a little bit of an overhang, and the geometry also is accommodated with this because of the it's not entirely straight. You see, it's the main piece actually is set up to overhang the start of the geometry. So this can be done either by manually adjusting the transformation of something like a main piece or the cap, or what you can do is say, okay, since we are working with the instantiated geometry, and only thing that we are really doing is moving points around. So what I can do is say that for tool to say that this cap start is actually smaller than it actually is, and this is where the adjust piece sizes comes in handy. If you go to the here and say I want to adjust the cap pieces, and you press on initialize cap pieces, since I have already pressed it, you can see that you can offset the sizes of these cap pieces. And since I know that I'm using the cap start 0, it's going to also give you a name of the cap piece and the size of it. So what you can do is go ahead and you can see I have offset it on the negative. So that means that this geometry is now internally processed as being smaller than the attribute that is being provided. So basically you can imagine that for the cap start, uh, whatever the value we have written in the size attribute, 0.40, with this parameter we are offsetting that by negative 184. And how it works is basically that means that the next geometry is going to start sooner. If you go ahead and work and start playing around with it, you can see I can make this geometry to start sooner because the tool thinks that this geometry is smaller than the basically the size of it is being made smaller internally on it. So this is a great way to adjust pieces because we do not have to change the transformation of the actual piece. And to work with the end of the cap, we have to go ahead and adjust the straight piece. Go to the straight pieces, you can see I have already adjusted the size of it. You can see if I want to overhang each piece, I just go ahead and say it's actually a little bit smaller. A little bit smaller than this. You can see we're getting this overhang. And that's pretty much it. So this is a little bit more advanced usage. And as long as these corners are not too sharp, it's going to work really nicely. And the tool also gives you option to convert to the subdivision curve. So by default, these curves are pretty, especially something like this, it should work just fine. But the conversion to the subdivision will get you more rounded look. You can see here we have these sharp corners that may look fine or not, but in this case it probably makes sense to convert it to the subdivision curve to make it smooth, something like a road. When you have a road and you need corners, like for the road corners to have this railing. So this is basically the Pathdeform mode in a big picture way. The next mode that I want to talk about is the railing mode. Railing mode introduces new attributes. So in this case, we are introducing attributes something like 2 more attributes from the Pathdeform mode. So we need our angle, and we need our next piece offset, and we still need our size and ID. So how it works actually, it's the geometry is being set up. So this is a great example for the geometry that is suitable for the railing mode, since the geometry is from the Megascans, this one. So you can see that in this modular safety rail kit, we have basically 4 pieces. It has the main piece, the cap, and then we have two pieces that goes from the one that goes to the left and one for the right. And in this mode, we can actually differentiate angles that go to the right and to the left. And this is why this tool actually works. And you can see, take a look at it. You can see we are instantiating for the corner that for the next corner that goes to the left, we are instantiating a left corner, and for the right, we are instantiating the right corner. So how it is done? It's by setting up attributes correctly. So let me show how it works. So for the straight piece, we are setting our size. We are still using our bounding box size. For the offset, we are actually setting it as 0 because we can actually go ahead and adjust this size offset inside the HDA. So that's if you want to quickly create your not to think about the offset of this geometry, you can just quickly add it as 0 and edit inside the HDA. Then we need our ID, and then we need our angle. In this case, the angle is going to be 0 because it's going to face straight forward. So for the cap, also the same thing, bounding box Z, offset 0, cap, angle is going to be 0. And now we have to take a look at these, how the corners are set up. In this case, size is also Z, but in this case we have our angle set up as negative 90 degrees. So you can see that, so it's a little bit counterintuitive, but the negative 90 and for the other one, for the left one is the positive 90 is because of how the geometry has to be set up on the relation on the z-axis. You can see when we are looking forward on this z-axis, you see that the positive x-axis is actually going to be on the left of us, and the negative is actually negative z-axis is going to be on the right of us. So this is why the kind of naming can be counterintuitive, that the negative is actually on the right and the positive is actually on the positive is actually on the left. So if you're confused about the y 90 degrees left and directions of it, you just have to look at the z-axis, basically on the x-axis relative to the positive z-axis. So as long as we have set them up, we can go ahead and instantiate the geometry along the curve, and it's going to be automatically picked up. So this is also where the snapping comes into handy. So when you have your the tool can actually snap to the first angle that divides with this value without the fraction. So in this case, I have already created my geometry with 90 degrees corners, but let's say I have maybe a little bit of I have not done it perfectly, something like this. The tool should still work nicely because it has, you can see now it's a little bit not aligned completely because of the adjustments for the angles, but you can see it still retains the 90-degree angles. So let me actually go ahead and make this back to 90 degrees, but we should so this adjustment was made because I have adjusted the first point on the polycurve. So you can imagine that once the first point has been adjusted, it's going to adjust everything after that. So the rotations doesn't happen if you are editing something like last points, because the tool has already checked everything before this one, and it's going to only try to rotate everything after that it has already snapped to those angles. In this case, it's going to be still snapped to this one. And the snapping is actually very useful for something like in this case. Let me showcase this one. In this case, I am also using a snapping angle, but it's a lot less aggressive in this case for the railing. I made the snap angle to be at 10 degrees, and this can be very nicely seen in something like here. So in this one, you can see that I since I drew this polyline by hand, you can see it's not entirely it's not completely aligned with the axis. So let me actually go ahead and go to maybe something like this. So this is not railing would not be completely a little bit crooked. So what's cool about this tool though is since the snapping is enabled, you can see that right now the polycurve has been snapped to the closest 10 degrees. And since the correction is very small that needs to be done, you can see if you go ahead and compare the original curve, which is the one that's below, and the adjusted curve, you can see it has been adjusted to be on the increment of the 10 degrees and has basically automatically straightened out. So this is another benefit of this tool, that if you go ahead and snap your angle to something like here, you can go ahead and kind of straighten out your polycurves that needs to be more straightened. But if you do not want to do this, you can just put the snap angle to something like a 10 degrees. So something like a 1 degree, I mean. So let me go back to this railing. So this is how the angle detection has been generated. And to make sure that you that this angle is being followed, go to the bend mode. Actually, in the railing mode, you have to go ahead and say distinguish left and right angles for flat angles. You can see if I disable this one, you can see that right now the tool is not distinguishing the left and right angles, and it doesn't look correctly. And if you press it, it's going to automatically align them. So this is a pretty basic implementation of the railing mode. Let me go ahead and show you another implementation of it. A more advanced railing mode implementation is shown on the example, in the second example. In this case, what I'm doing is actually I'm generating geometry along the some of the corners, and for the rest of them are actually instantiating geometry. So let me show how it actually is set up. So you will notice that on the railing mode, there is a reference to the flat angles, and the flat angle is in this case is being described as something that where the incoming polyline. So the flat angle in this case would be something like these two corners, this, on all of these, because of basically the incoming polyline for the corner and outgoing polyline are all basically their y heights are roughly the same as with these two. You can imagine that these two corners would not be considered as a flat angle because they're actually going downwards and like that. So what's cool about this tool that we can actually, to demonstrate one additional feature that this tool has, is actually let me say I drew out this polyline and it's not completely and I have intended them something like these polylines to be flat, but since I'm drawing it by hand, let's say there's a little bit of imperfections on it. So what's cool about this tool that we can actually snap to the closest. So the tool basically internally kind of groups many of these points that are in similar height into its own group. It's going to flatten them out. And to show how it works, it's actually you see the end of it is actually being already flattened out. You can see it at the end of it, even though it's not completely straight setup, I changed them a little bit. You can see that right now this geometry is being instantiated and it is considered as being flat. So this is because of the tool of the snap Y position. If I disable it, you can see that wherever I created a little bit of imperfections, they are no longer considered flat, and the geometry that is very similar to the flat angles are being generated around these corners. So this is a very useful thing for you to snap Y positions like that. It's going to modify it a little bit, and it's going to straighten out the points that are in very similar height position, in very similar height values. And how the tool is set up for these bends is pretty simple. Let's go to the railing mode, and whenever we are saying I want to basically have to provide our geometry. In this case, I have a lot more geometry that is basically bent around the negative and positive axis that the tool can choose from. You can see that I have bends from 0, I have straight bends, straight geometry, 0, I have cap geometry, and I have also all the bends between 0 to negative 170 degrees on both left and right sides. And this is what the tool uses to generate the geometry. And whenever there's no flat angle, it's going to go ahead and take a straight piece and bend it. And this bend is generated in these corners. You can see we have to provide the piece that we want to bend. So I have 3 straight pieces. I can say, okay, let me bend the second one. You can see the second one is a little bit different in geometry. It's being basically bent around the corners. And that's pretty simple for the bends that doesn't have an angle to instantiate. And then you can also change the bevel amount. You can see, and the bevel, you have to be careful not to be too close to the angles, because at some point it's going to start to break. So just make sure that your bends are within reason. And we can also enable fusing if we are generating geometry, or if there's like a more geometry that is, so we can't fuse the instantiation. But if there's geometry that is, in examples like here, when the bend is so severe that it has to take 2 corner pieces and bend them together, we can just go ahead and enable fusing, and it's going to fuse them together. So in this case, I have only 1 piece, and it doesn't really make sense to fuse them since it's not going to do anything. And I can also disable the instantiation of the corners and say, you know what, I want all of them to be bent. And I press on or bend all corners. You can see it's going to be now bent. All the corners are going to be bent. So in this case, I have a lot of instantiated corners, so let me disable that one. And again, I have my output curve. I resample it, I copy it, add some material, and that's it. And for the output curve, there are a couple of options that you can have to have maybe a little bit better results when you instantiate geometry. So let me show you in this output curve. There are a couple of things done like instance corners. So whenever you instantiate geometry, there are no real reference to the geometry that is being instantiated and how it follows the geometry. So we basically have to do a little bit of a guessing on how the corners are being applied on this one. And in this case, if I do not nudge my corners, instance corners, you can see that this geometry is not really very well aligned. This curve is not very well aligned with the rest of the geometry. So what you can do is, so I have made this parameter, basically just the corner nudge. Let's say I want to make it a little bit bigger bevel for the output curve. I say, you know what, nudge all the corners a little bit more. So this is going to make the corners output curve to be better aligned with the geometry. So this output curve is very much still work in progress, and I'm really looking forward to some feedback on this feature also. And then also there's a cap feature, as I displayed before. We can cap our polycurve like that. So this is a railing mode that's pretty powerful if used in the appropriate instance. Before we go any further, I want to talk a little bit about the offset attribute. So for something like this case, I'm also use the offset. I also use the offset attribute inside this in this railing mode. If you go to the adjust piece sizes, you can see I have used quite a bit of these offset for the corner pieces. Let's actually go ahead and maybe let's make this corner piece offset 0. You see that now the geometry actually looks very incorrect. So the incoming, let's actually take a look at the polycurve starts at the 0, like that. Let's take a look at this one. You can see that the first corner looks all right. It connects pretty well with the first corner, but the output is completely wrong because it takes the corner, but the next piece begins already. Basically, it doesn't give enough space for this piece. It's basically the next straight piece starts right at the end of this one, and this is because of the next piece offset attribute. Since I wrote all of them at 0, the tool gives it basically the offset is 0, and that's why this is going to be offset immediately after this one. It's not going to be instantiated right after this one. And the best visual way to look at this size and next piece offset attribute is with this picture that I made for the documentation for the tool, which is going to probably be used. You can imagine that if both of our offsets are put to 0, and the instantiated geometry is basically aligned with the positive z-axis, it would look something like this. The straight piece starts and ends at the instance corner, and the next starts here. And you can imagine that we have not given enough space for the instance corner to have a appropriate space for it. So we can imagine that if we put down an input in offset and out offset attributes, you can see that now we have offset for the input of it and the output of the corner, but the point is still not offset. But if you go ahead and so the offset can happen in multiple ways, but the easiest way for us is basically offset the instance point that this geometry is going to be instantiated, basically moving it backwards to the start of this geometry is basically where this incoming straight geometry starts. We want to move our point there. And if we have moved it, you can see now the corner is going to be aligned perfectly. So this information should be set up on the attributes in and out offset. In this case, I have my offset and the size attribute. But if it is not set up, like in this case, we can go ahead and do it with the tool, which gives you a little bit more of a more interactive way of aligning these pieces. So let me go ahead and do it right now. Let's go to the adjust size pieces. Let me actually go ahead and put all of them at 0. I'm going to actually go ahead and instantiate all of them again. So in this case, you can see also the sizes for the straight pieces are a little bit too big because they are not actually connecting to the next one. So let me go ahead and change the size of the straight piece first. Right now, let me go ahead and adjust it. Something like this. See, if I change the size of it, it's going to do something like here. So the small piece, so the straight piece has been aligned correctly. So now this is the corner. The corner connects just fine. Now I want to give it some space for the next one. So go ahead and go to the corner piece. Let's check it out. So in this case, I want to go ahead and align it to the next one, something like this. Then I want to go ahead and the next piece offset, which has to be pretty big because we want to make sure that it has enough space. You see, by moving these corners, we can go ahead and align it perfectly along. Something like this. And since this is all instantiated, this is going to work just fine with all of the corners that look like that. Now all we have to do is go ahead and repeat it for the next one. And we can basically just copy these values for the second offset piece also, since they are basically the same. You can see now we have basically repeated the setup that I had by correctly offsetting the instance points. And this is great because we are not actually touching the input geometry. Input geometry can stay like that, and we are just moving the instance points around. You can see there's a bug inside Houdini that I have to remove and copy this material node. That's a little bit of a going back to derailing mode. And the next mode I want to talk about is the pattern mode. So the pattern mode is actually very unique because it does not require you to have any polyline at all. It's called the pattern mode, and it actually uses the pattern that we can write inside the common attribute parameter inside here, and it uses the vector attribute that is set up for each one of these modular pieces. And each one of these pieces has this attribute that basically describes where the next instance geometry should be located for each one of these pieces. So you can imagine that if we are instantiating this geometry, for this geometry to connect to for the geometry to correctly align this one geometry, the next geometry piece should be copied something like here at the end of this geometry. So this is where the attribute value of the, in this case I call this a size attribute, and you can see I have not actually set this up correctly also inside here, because we can actually do it more precisely and interactively set this offset value for the vector attribute inside tool. So let me show how it actually works. So in geometry here, you can see that there is a pattern, and the pattern actually introduces a new syntax in this mode that is used, basically uses, that can be used in also other modes, but this is a very useful syntax to have in something like here, where we have to repeat a lot of times the same geometry. It would, the square brackets are used to repeat the same piece multiple times. And how it works actually seen in the parameter that is at the very top of this HDA, which should probably be set to the invisible, but for the demonstration sake, I went ahead and showing it. It's basically just a Python script that evaluates this pattern and expands it to the something that HDA internally uses to see what kind of geometry to instantiate. You can see that if I have straight underscore 0 a pattern, you can see it's going to be expanded to the 4 straight underscore 0 strings. And if I change it to something like a 2, 3, it's going to automatically set like that. And to show how interactively you can create these offsets for this tool, you can go to the adjust piece sizes, and let's say I want to adjust just the next instance point for this cap point. Let's go to the cap pieces. Let me put it at 0. You can see it now. It's not going to be aligned correctly because this, and now we're using the bounding box size as a next place where to instantiate geometry, and this is not correct. So what you can do is go ahead and just work with these pieces. Just very interactively, you can just go ahead and make sure just that you align them precisely like that. And what's great about this way of working is that you can align these pieces basically interactively, and then you just can copy these values inside these inside the attributes of this geometry, and then it basically save these values that you have offset on the attributes, and then basically export this geometry again. And then next time you are actually importing it inside here, your offsets will be correctly set up, and you won't have to do it manually. But if you need, you can just do it like that. So, and to showcase, I have all the setups, all the offsets set, and I want to straight, and then I want to corner, and then I want to my straight 3, maybe like a 5 times. You see, we have now created this kind of a geometry without a polycurve, just by stepping through the pattern here. So yeah, so this explains the pattern mode, and also the start and end caps are supported, but since I don't have end cap, I'm not going to use it. And if I disable, you can see the end cap is not here. So this mode is very interesting, and there's plenty of ways that we can also improve it. So I am very looking forward for your feedback. And the last mode is the one mode that I already showcased in my previous video, which is the pipe mode. As you remember, the pipe mode is the kind of like a original idea that I had, that kind of exploded this HDA into things that it has become. There is the angle-based instantiation, where the geometry can be connected to the straight geometry at any angle, and it'll be instantiated along the curves with however you want. So I'm not going to go through this mode too much, because I have already talked about it in a previous video, how it's actually set up. So this is all 5 modes in a little bit more information and kind of a overall global concept of this HDA. So I want to thank you for listening to me, and I really hope you try this HDA out, and I really hope that you give me some feedback on this HDA, and for any updated information, I want for you to go ahead and take a look at the pinned comments on this video down below and see whatever updates I have written there. So that's it for this video. Thank you for watching, and see you next time.